So Josh, if engineering were a cheeseburger with onion sauce, you would be the hot, yellow, petroleum-based cheese product dripping from the undercooked bacon.
Welcome to Engineer vs. Designer.
The podcast.
For engineers,
designers,
makers, breakers, and those who design a paper-based 3D printer. I am Josh.
And I'm Adam, and as always, we'll be making fresh product design smoothies from the squishy stuff between the ears of our esteemed guests. This week, we have the great pleasure to speak with the one and only Conor MacCormack, CEO and co-founder of MCor Technologies.
Makers of the paper-based 3D printer currently in use at Staples locations around Europe.
We'll start with a design history lesson courtesy of SolidSmack.com.
Sure will, followed by a cool design area tip talk courtesy of Cadjunkie.com.
Where I might attempt to recite the entire Latin alphabet backwards with a mouthful of extra crunchy peanut butter.
Sounds
Do.
messy.
Speaking of eating throat-clogging plant matter, Josh, massage the bulging udders of ignorance with the powerful dairy farmer hands of knowledge. What have you got for us this week?
This episode of Engineer vs. Designer is brought to you by our very own Cadjunkie. If you want to learn of black belt ninja skills in SolidWorks, Moto, Rhino, or how to sketch footwear using Adam's patented Photo Illustrator technique, check out over 50 hours of video training at cadjunkie.com. And you know what? We've sent out a tweet for this episode. As we do,
we have.
Anyone who retweets that message will be entered into a drawing for a schmancy fancy Engineer vs. Designer t-shirt.
Made of gold thread.
It's true. Last week's winner...
And cotton. Mostly cotton.
Last week's winner is... Nick Hunter.
Nick Hunter. Nick... Congratulations.
There you go.
You could be next, you listening right there with the earbuds in your ear holes. Head over to twitter.com/EVD1 or click the link in the sidebar.
Yep. As you know, we're talking with MCor Technologies CEO Conor MacCormack this week.
The guy went from aircraft engineer to printing 3D stuff out of paper. Very cool stuff.
Wow, indeed. So this week we're going to bring you the history of paper.
Actually, not really. That would be really long.
Yes,
But instead, we're gonna talk about cutting paper instead. How about that?
Sounds good. Well,
all right.
The oldest surviving paper cutout is a symmetrical circle from the 6th century, Xinjiang, China.
The oldest surviving paper cut dates back almost exactly that far.
Now, the craft filtered throughout Asia and Europe, where many countries developed their own style of paper cutting.
It's been used for everything from religious decor to furniture templates.
Funeral ceremonies to embroidery patterns.
Now, Turkey boasted a guild devoted exclusively to the task of paper cutting.
Wow.
And in 1582, it displayed a portable garden made entirely of cut paper flowers.
Insane. Yep. Now, Danish storyteller, you all know him, Hans Christian Andersen, was an avid paper cutter himself.
Yep.
You can see a display of his work at his home in Odense, Denmark.
And the Swiss even developed a method of layering cut paper in a type of collage, like three-dimensional collage technique, very similar to this 3D printing stuff.
Li Hongjun is a modern-day paper artist creating surreal sculptures from layered paper, and you can't forget the colorful craft of Maud Van Tours, who also does this layering, paper after paper, then cuts through them to reveal these wonderful shapes and patterns. Just amazing.
And actually, if you want to go back and listen to a fun Engineer versus Designer episode, check out episode 12 from October 17th of 2011.
Yes,
That's
I
Robert
that
Sabuda, pop-up book designer, does incredibly cool stuff with paper that you would not believe. Yeah. Definitely worth a listen.
Yeah, he does. You know, imagine if the ancient Chinese had one of these printers.
I imagine we would see some... I don't know, masks and dragon costumes. Yeah,
you could use a paper mask right now with without a mouth hole.
Come on, man. This episode is, of course, brought to you by Cadjunkie. If you haven't visited the site in a while, we've been doing some major upgrades in the last few months and have been pouring out great new real-world project-inspired SolidWorks and Moto training. Definitely want to go check that out over at cadjunkie.com. And, yeah, so Josh.
Yes.
I actually, in the room next to me right now, I'm actually looking over at it. I have a MakerBot Replicator 2 3D printer sitting on my shelf, and it looks really nice over there. And that's most of what it's been doing for the last few days.
Just sitting there.
Looking really nice. Yeah, it looks nice.
Giant $2,500 paperweight.
You know what? It's a super cool thing. And if you print any of the default objects that come on the SD card, boy, is it cool. Because I've got this little, the little nut, the nut and bolt that come on there. Yeah. It's like there's a nut and a bolt, and you print them out, and they can go together. They screw together. Ooh. And there's a really cool like knurled texture on them. It's very fancy, and it comes out perfectly every time. It's great. The problem is that whenever I go to print something that I've made, the results are not so
jacked
great.
up.
I've been having a lot of trouble. Yeah. I've been having all kinds of problems.
So there's a certain amount of preparation that goes into printing a model.
Yeah, there totally is. So the first thing that I figured out with this thing is that, and I'd actually kind of anticipated this problem, but I was curious how they would solve it, is the lack of support material. So on a lot of 3D printers, you know, like, well, there are tons of different processes, but most of them have some kind of support built in, where if you have undercuts and stuff like that, you know, those things will be kind of, there won't be hovering out in space where they just fall. Whereas with the MakerBot, there's no support. So if you tried to model something out in space, it's just squirting plastic out into the open air, and it will do that. If you give it a program with no support built onto it, it'll just start squirting plastic out into the room. And I have some great photos of this hairy, blobby mess that it makes when it does that. And so you have to build in support. And the software can do that, but it's kind of excessive and a pain to take off. So I don't know, man. It's not been the magical experience I was expecting.
Well, you can build in your own supports, right?
You can. You can use this, right.
That
so
requires
if you don't
thinking, which you have some trouble at sometimes.
Exactly, man. Well, I actually, so I was going to build a tripod mount for my iPhone, right? I designed a tripod mount for my iPhone so I could put it on my normal camera tripod. Thought this was a really cool application. So I started, by designing it, I started printing it out, and it kind of was too thin and frail and fell over. And so then I tried it again and again and again. I've done 4 or 5 prototypes, and I can't seem to get this thing to work. I built supports in SolidWorks. I've actually gone to the effort of like actually just making all of the supports in SolidWorks so there are no undercuts. And just kind of making intentionally weak areas in there so I can break off the supports.
Nice.
But it's still, I'm still struggling with it.
Still not there.
Yeah. So that's actually, we're about to talk with Conor MacCormack of MCor Technologies. They make this paper-based printer. What's cool about that to me is that it's a lot like Z-Corp or some other layering technology where you end up with the paper itself acts as its own support material. You're not going to have any of this problem that I'm having, which is kind of great.
Just sort of cuts it out. Everything's self-supporting there. Just take away the paper after you're done. Yeah.
Yeah, totally. So anyway, you know, I guess I would just say the MakerBot is incredibly cool, right? I got this thing. I got the box that's really cool looking, and I pulled out. The packaging is really thoughtful and well done. It's really fun. You take this thing out, and it's super exciting. And it takes literally, if I weren't taking photos as I was unboxing it, it would have taken me 5 minutes to be printing my first print. It's just incredibly fast and simple. And so I love the MakerBot, and I'm still hopeful that I'll learn how to use it. But it's not been as easy as I was expecting. So
you might figure
stay
it out.
tuned.
If anybody has any tips for Adam, send them in.
Please do. Please do. Well, Conor MacCormack, thanks so much for being with us today. We have one conundrum for you as we start off the show. If you could choose between having copious amounts of cottage cheese explode out your nose every time you sneeze, or involuntarily belch loudly every time you hear the word dinner, which one would you choose?
Dinner.
Belch.
You're not gonna.
I don't like cottage cheese.
Oh, okay. All right.
Okay, Connor. Before we get into the gritty details here, who exactly are you, and where did you come from?
Where did I come from? Well, my parents probably have a different answer than
Right.
that, but effectively,
Let's keep it PG.
Yeah, well, I'm from a little town not far from a factory here, a place called Ardee, Ardee, in County Louth in Ireland. My background is in engineering. I've worked around the world before I kind of settled back here setting up MCor Technologies. So I've traveled around a bit, worked a bit in the US. Always kind of wanted to do engineering as a kind of a main driver all the way through my kind of school years. My father is a high school engineering or metalwork teacher, as they used to call them in the time, but a metalwork teacher. So always had a very keen interest in engineering. We used to, build motorbikes when we were kids, strip engines from Honda 50s from when I used to have my brother when I was like 8 or 9, like working in the garage, getting things together. So I always really wanted to do that. And
now, I'm sorry, but to say you're an engineer, I mean, that's definitely true, but possibly an understatement as well. I believe you have a PhD in mechanical engineering. Can you tell us a little bit about the transition from working in your dad's garage, stripping down motorcycles, to that kind of rigorous education experience?
Yeah, so I kind of went through the long way kind of through college. I didn't go straight to university right off the bat. I went to kind of like a technical college initially. I got my kind of technician background, and then I did a diploma in engineering, but it wouldn't have been a full degree. Then I worked in the field doing technical drawing, as I was talking to you earlier, like drawing with ink and designing transformers actually for power supplies. And then I got the opportunity I got a career break, and I got the opportunity to go back to college, go to university, did my primary degree in mechanical engineering. Then I traveled a bit into the US. I worked for a couple of materials handling companies. It was probably giving me a lot of background information for, how to move things around in machines, belts and pulleys, linear slides, that kind of thing. That would be the basic, nuts and bolts of what any kind of machine that we make now is kind of all based around that. And then I got the chance to initially, I applied to do a master's in aerospace structures and materials in Trinity College, which is a very reputable university, the top in the country. And the course, actually, I got accepted, only one of 2 people to get accepted onto the course. Wow. So the course didn't run because only 2 people went for it. So nice. the head of the department actually rang me up. I was in Philadelphia and said, "Would you like to do a research master's in using materials, using finite element analysis, stress analysis of bulk metal forming, of how materials kind of deform on the load?" So I came back for that, and within the first year, I transferred from my master's degree. I did a transfer report, and if you can get past your transfer report, they'll enable you to transfer into a PhD. So after my first year master's, I transferred into a PhD, and 2 years later, I got a PhD using primarily finite element analysis to model metal forming, how metal kind of forms under huge pressure.
So that's really interesting. Actually, I'd like to take one step back to something that you're saying. I mean, it's really unusual, at least with the people that I've spoken with, for somebody to go to a PhD level and then not disappear into the ivory tower after that. It seems like you've done an unusual thing by getting a PhD and then going back into making machinery. Do you think that's do you think that's unusual?
Well, it was very important for me. I mean, I've always kind of chosen a path in my career that would enable me to do real engineering. Mm-hmm. And when I got my PhD, I then started working with Airbus, working on the denting of the fuselage on the A380. That's primarily what I spent my last couple of years before we set up MCor. So we would take a design. I wrote a program that would enable part of a fuselage by specifying various dimensions and stringers and thickness of the aluminum or whatever. It would build it up in 3D in the finite element package, and then we would impact objects into it and see what the stresses were. And then when we had predicted the stresses, they would actually, Airbus would go off and build the panel, actually deform the panel to the level on the computer, and then actually measure, see what the stresses were, and try and validate the. So, I know a lot of people, like most of the guys that I would know in university, would usually go into some sort of a management structure, and they wouldn't really do any real engineering. It might be an engineering company, but they're not doing any relative engineering. So it's very important to me to stick with that, and that kind of obviously that's transferred all the way through to setting up MCor.
Well, how you transitioned into 3D printing is going to be an interesting story here. But
from Airbus.
First of all, riddle me this: the top 3 execs at MCor, you as CEO, Fintan as CTO, and Deidre as CMO. You all share the same last name, McCormick.
Yeah.
How are you guys related? And should we assume that MCor is a little bit of a play on your name there?
Yes, absolutely. Yeah. So the Fintan is my brother.
Okay.
So, and Deirdre is my wife. That's the simple. Yeah. So yes, and MCor
all
is
makes
a play
sense
on.
now.
Yeah, MCor is a play on the surname, and we also it is an important. It sounds kind of maybe obvious now, but even from the very start of setting up the company, we see ourselves as an R&D company. You know, where our strapline is MCor Technologies, unfettered innovation, and we really do believe that. We didn't want to name ourselves after a 3D printing type of technology or to say 3D printing, because we believe that this company, you know, that we can come up with innovative ideas about a whole lot of other products down the line, and potentially even into different areas. But obviously, like taking one sector like 3D printing, you know, we have to work and get through this in the first place. But just to give an idea that we wanted to pick a company name that was not necessarily associated with our 3D printers, so that would enable us to go into other products and for the longevity of the company.
So on the topic of 3D printing, your first technology, how did that evolve? How did you go from Airbus into 3D printing then? Yeah,
well, it was my first ever introduction to 3D printing was a show in the UK called Tomorrow's World, and if you go and look in YouTube and type in Tomorrow's World, you'll see some of the kind of early shows. But they would show all these kind of what if, you know, like flying cars and all these kind of things that were going to happen, their predictions on it. But they had one of the, I think it was in '86, they had a kind of it had the laser stereolithography into the resin, and I just remember I was completely blown away by it. So from that point, if you fast forward to when I was working in Airbus and doing some postdoctoral work in Trinity College, they had some 3D printing machines both in the university and in the company. And we realized that at that time, maybe only one student in the product design course at the end of their product design year would get to print out a part, because it was going to cost a couple of $100 or more or euros to print out an object. And the same with the companies, even with the big companies, they weren't utilizing them to the full extent that the whole idea of a 3D printer to print multiple prints, multiple different design scenarios, and not really have to be worried about the consumable costs. You know, I felt that was the missing key here, that something really needed to change, and to move it from going from a few thousand of units per year. Well, like, why was it only doing at the time, you know, 3,000, you know, around 2002, 2003, it was only around 2,000 to 3,000 units per year, like globally, which is, you know, ridiculously small number of printers.
Right.
And,
well, don't you think? I mean, let me play devil's advocate here for a second, because I'm not sure that that my information corresponds with yours here. I think you know, the capital cost of 3D printers was definitely very, very high. It was very inaccessible to buy a 3D printer from one of the big companies.
Well, how many years ago was this?
However, I mean, even just you know, quite a while ago, you know, Z Corp was making printed parts out of cornstarch and super glue. They were cheap to make. The individual parts were cheap, and FDM printers as well. You know, you could print something for $10 or $20 once you had the machine. So, I mean,
yeah, it's all, well, actually, I'll have to pull you up on that now. You pull me up, I'll pull you up.
Yeah, by all means.
Back in 2000, when we started looking at these machines, and when we started coming up with the concept of the 3D printer, Fintan and myself, the two of us together at that point, you're talking about the machines would have been in euro, probably 45 to 50,000 euro for a Stratasys machine. And the Z printers were probably a little bit cheaper, but not much. So as you're correctly, like, it wasn't just the price of the consumables, it was the price of the machine at that point.
Right.
But we knew that that the consumables was the biggest part. Like, you will be able to buy that machine, but if you're going to be spending a lot of money every time you print something, that's going to be a big issue. Now, if you fast forward even to, you say now they're only a couple of bucks to, or $10 or $20, like the cost per cc for something like ABS plastic, which is, you know, something that, like with the maker bots and the kits and all that, can get very, a lot cheaper.
Right.
Like Stratasys and these type of companies, you know, they've made a very big revenue stream. Maybe 40-50% of their business is made up from the consumables, from the revenue. So you might say that part is cheap, but it'd be very small for something that's only going to be $10 or $20. Like, if you want to be able to not to be constrained to the size of your print, to be able to print whatever you want, that's what we wanted to do. That's what we wanted to make, a printer that the people didn't have to think, what was it going to cost to make a part? And we knew that at the time, and it's changed a little bit now, but it still holds true, that people didn't really care, especially in universities. They didn't care what the 3D printer made it out of. You know, that there was, as you said, there was cornstarch, there was powders, there was all these different technologies. Yet they were teaching it to their students, but they couldn't afford to get the technology because they couldn't afford to run it in most terms. That's the way we went.
Well, so that's a perfect segue then. So tell us about the development of your 3D print technology. It's clearly a very different approach from what's out there. Can you tell us about it?
Yeah. So as you say, we looked at it completely differently. So we would view ourselves as having an inverted razor and blade model. So everybody else is reducing the price of their machine. So the razors effectively are getting cheaper and cheaper, but the blades, you know, the consumables are going up in the opposite direction. So it's not enough in our view just to reduce the price of the machine. You have to also have very low running costs. That's the only way we believe it's going to happen. So we completely looked at a different angle, turned it upside down in its head, and we wanted to build a machine at that time that was going to have effectively virtually very low running costs, that you wouldn't really have to worry about what you're going to print. So we said, what's the most readily available material that you can get your hands on? You know, that wasn't depositing a layer of powder. We weren't going to be going into plastics because of the cost of plastics and potentially the smell of plastics and all the things that you might have to worry about with plastics, and with the powders, the dust, and you know some of the complexities of that. So we said sheet paper. Everybody can grab their hands on a couple of reams of paper. You can go to your local office. You can go into your store. You know, within a couple of minutes, you can grab your hands on a few reams of paper. We said, let's start there. So the sheet material is going to be paper, and we're going to use a water-based adhesive. So from the very first weekend, when Fintan and I came up with the concept, it was paper and a water-based adhesive. And we said, that has to be simple. Like, how hard is it going to be to stick a couple of sheets of paper together? And it actually turned out to be one of the most difficult challenges, because a water-based adhesive, as the name suggests, is made up of water. And when you put water on paper, the paper blisters.
Mush.
And to get around that problem, then we could have went down to a solvent-based adhesive that would have made our life a lot easier, but it wouldn't have been an eco-friendly printer. And right from the start, we wanted it low cost and eco-friendly. So that was the starting point. Simply from that idea, let's pull in sheets of paper, use a water-based adhesive, and instead of using something like a laser that will cut the paper, because laser and papers aren't a really great combination when you think of fire potential.
Hazard.
We said, let's just use a tungsten carbide blade. You know, we'll cut out the profile and we'll just go with that. And that was the start. That was the start of the concept. In the early days, as I said, 2003, I was working in Dublin. Fintan was working in Philadelphia. We both had our ordinary jobs. I would come home in the evening. We had one daughter at the time. Get my daughter to bed, and then I'd start working. Fintan would come home from Philadelphia from his job, and we'd start working through the night. This was prior to Skype or any of those things. We were using 3 or 4 different packages, one for voice, one for sharing a desktop, and something else. We were able to get the whole thing kind of working. And when people talk about having an in-house machine, the very first machine we built was actually in my house. It was in the front room of my house. It was all made out of extruded, it made out of extruded aluminum kind of box section material that you bolted together. Fitton would send over the electronics. He'd build the electronics in Philly, send them over FedEx, and I'd attach it onto the machine, and we'd try and get the machine up and running over the phone, which is quite interesting.
Right.
Wow.
So we realized then in 2004 that it wasn't going to happen doing it part-time. Like, we'd spent a year or two at it, and it was like, you know, we had something that was moving over and back, but, you know, it wasn't doing it. So we made the decision to leave our jobs. We left both good jobs in 2005. Fintan came back from Philadelphia, and we set up here then in Ireland, and we started the process then of building the first machine. So we literally worked in stealth mode for the first couple of years. And then Deirdre came on board. Deirdre's my wife now. Deirdre was working in advertising and marketing. She's a degree in marketing and a master's in advertising. So she was working in that area, but for different companies. And it was a perfect connection. We needed to get a bit of press around 2007, 2008 to get a bit of awareness for raising investment and to let people know what we're doing. So Deirdre came on board. There was a couple of strategic placements of articles, and this is what we're going to do. We're going to make a 3D printer that ran on paper.
Right.
We got 2 million hits on a website in 10 days. Completely crashed the server. So like all of a sudden you could hear the emails coming in just every couple of seconds. Bling, bling. Emails, sales inquiries. So we knew then that people, if we could build this machine, that people would want it.
If you build it, they will come.
That's it. So, and from that point, so that's really how we got into it. But I know it sounds, you know, it might sound corny, but this is the truth. You know, we got into 3D printing to really upset the status quo. We didn't get into 3D printing just to go and say, this is how we're going to make a quick buck.
Right.
We felt that 3D printing needed to change. Now, this is prior to Desktop Factory. You know, there was nobody else in our mind was doing anything like this. And if you look back, and there wouldn't have been in 2003, you know, we realized that these big companies were making a huge, you know, kind of a profit on us, people who wanted to print parts. So we really wanted to make a difference, and we felt that by doing this, that it would enable that, it would kind of open up that floodgates. And now I think with the colour, that's another thing altogether. With the new colour iris printer, we've taken, you know, what the machine is very good at, you know, function in a form and fit, you know, where people can have very smooth surfaces and parts that fit together and dimensionally very accurate. Now we've put a layer of colour information on top of that, and we're breaking, not only are we doing some great things in the commercial, we're obviously into the consumer space with a price point and a colour part that really is impossible for them to get anywhere else.
Now, sorry, go ahead, Josh.
I gotta ask about this because it almost seems sort of an afterthought. The software side of the 3D printing, is your software easy to use? Do you develop it yourself? How are you guys developing that?
Yeah, so that sounds strange, but like we were so caught up for years building machines and telling people that we were machine manufacturers. It wasn't until a couple of, you know, maybe 3 or 4 years ago that somebody was in and we said, well, we write the software ourselves. So like we're software manufacturers as well. So we've developed the software. Started off, Fintan is the main driver on the software side. So it started off using like MATLAB way back in like 2003, 2004. Then moved over, we used a bit of C, and then it moved over to kind of Java base. And so now it's all developed here. We have programmers here in house that take the whole thing. So we'll take. Wow,
if you don't mind me asking, how big is your development team?
The software side is very small. It's only a couple of programmers, but the main thing is it's the thought processes behind it. It's coming up with the algorithm. It's coming up with how we're going to do this, and then it's just the implementation,
making it easy to use for the
absolutely
consumer. Yeah, and that's the big problem, I think.
Sure, like the things we're doing now, you know, is optimizing and opening up larger and larger parts. You know, because now with the color, you know, people are sending files usually a lot bigger now when you have the color information on top and optimizing it. And so it's great stuff for me to go out and to look at how the software has come on, and every time you see a new rev of the software and all the things that it can do, you know, you thinking back to where it was, it's brilliant. It's becoming a very nice product.
Now, I just want to review a little bit. So obviously, this is a really unusual and innovative way to do 3D printing. There are some great advantages to it that you've been talking about, the cost being one of them, full color being another one, now with the Iris 3D printer. And then there are other technologies out there, obviously, and I think those still have a place, right? So where would you say that the MCor machine fits into a design process, and where would you maybe want to go with a different, go with an alternative?
Yeah, I think you're correctly right. I mean, there's estimates out there that the penetration of 3D printing at the moment is somewhere between 1% and 8%. And I think it's closer to the 1%.
Sorry, 1% and 8% of what?
Of penetration, of how big it could potentially to usage. Like, there's very small amount of people that are using 3D printing that can be and should be using 3D printing. So there's loads of space out there for all the different types of technologies. There are some circumstances where people need metal parts, or there are some circumstances where they have to have plastic.
Right.
But realistically, when you start analyzing why people use plastic or why they use some other materials, there's very few that just have to have that. A lot of the times they want something that's really smooth. They want something that feels like a plastic part. And we can, people have a misconception of what our parts are like. They either think they're going to be something like a paper mache or some sort of origami type of folded object. But actually, when you get this object in your hand, because we press really hard in the machine, building the layers, we're actually putting it back into almost like a wood-like structure. So you hold these parts in your hand, you have something that's, solid and rigid, a lot more durable than any of the powder technologies. You can throw them into your bag, you can fly with them, you can take them out and bring them to demos. You don't have to wrap them in bubble wrap or anything like that. Like, these parts are durable. And if you treat them afterwards and do all that, you can make them just look like plastic. I could give you parts that you would say they're plastic, that's injected molded or something else, and you wouldn't realize it.
Yeah, the images on your site they look like real parts.
Really impressive.
You cannot tell they're paper at all.
No, but I do think like where our machine fits in perfectly is definitely at the early stages of the design cycle. So if you can print multiple parts on a very early stage and capture all the things that you need to do before you go down to another technology or to some traditional injected molding, that is really where it fits in. But the running cost on our machine and the total cost of ownership, once you start running the machines over time, you can easily take 10 or 20% of the work of our competitors' technology. So if we walk into a company that has our competitors' technology, their running costs on those machines are so high that we can say to them, even if you take 20% of the work that you put in that machine, you can buy our machine and start making profit. The running costs are so different that our machine can fit into loads of situations, a lot more situations than people might imagine.
These aren't desktop printers either, like the Iris and the 300 Plus. Just to give a little perspective on there, I'm wondering, are you ever going to be going into a desktop type of computer, or?
Because how big are these? We've got a video on SolidSmack, by the way. We're going to link to that so people can look at it, but can you describe how big one of these things is and kind of the footprint?
Yes, the machine, I can give you the metric dimensions. It's approximately, the machine itself is nearly 1 meter cubed.
Okay.
And you're correct. I mean, it does sit on a desktop, but it want to be a fairly good desktop.
Yeah, it's going to be a big desk.
Yeah, and we actually, with the Iris, if you've seen any of the images, it actually comes with a stand, because we were enabling people to, put the machine on their own table and they can get their own desk, and they can. But with the Iris machine, it's an integrated, so that they get an actual table built into the process. So, the machine at the moment is around 160 kilos. So it's it's a little bit different. But saying that, it's actually, I was going to say it's not as bad as some of our competitors, but our competitors now have new machines that are smaller and smaller.
Well, it's not as bad as some of your competitors, and others it's bigger. But I mean, it's not going to be a portable item. I don't think anybody's expecting it to be portable. So
so our obviously I can't share too much on our future development, but like our whole ethos as a company our vision really is to become the market leader. It's quite simple, providing low cost, eco-friendly and full color 3D printers. And I think for the way that we are going to have to do that is that, you know, like all products, the machines are going to get faster and faster. They're probably going to get smaller. You know, they're going to potentially get a lower price. So this is what's going to happen in the evolution of our products moving forward. And so I wouldn't say that that's out of the question in the future.
The colors of your prints rely on inkjet printing each page, though, right? Prior to actually cutting and gluing it all together. So isn't that part going to be, that's going to add a bit of cost to the whole process?
Inkjet printing is expensive, right?
Yeah, well, actually, it's all, again, it's another relative thing. So yes, I mean, inks are, okay, so you're correct. Our machine pre-prints, so pre-prints the ink onto the paper.
Yeah, just for the color stuff.
Oh wait, now your machine does the printing, does the inkjet printing as well?
Yeah, so it's a built-in printer. So in that stand underneath the machine, we have a regular 2D printer. The same software that controls the 3D printer that does all the control motions and slicing up the part also runs the 2D printer. So when it's making one part, for example, say the 3D printer is making something, you can get started on the next part.
Oh, I see.
You can print the 2D printer. It only puts ink where the cut is going to go. So we're very economic with the ink. So people would naturally have assumed that the first thing you would have done is printed out like a lot of photographs of whatever you want to make, like full images over the whole sheet.
Right.
But actually that'd be a very wasteful thing to do. So we only print the ink
just on the edges.
Sheet just on the edges, or if it's flat, on the visible surfaces. Mm-hmm. And what's unique about our ink is that most ink has, over the last 20 years, all ink has been designed to sit on the top surface of paper. So if you printed out a text, it only goes down like a micron or so into the thickness of the paper. If we did that with regular ink and you cut through the sheet, you actually get white on the side. You won't actually get a full colour all the way through the print. So a vertical wall, after you put that ink down, regular ink, you don't get your colour on the vertical walls. So what we had to do is that we have invented our own ink.
Oh, wow.
So it's our own patented ink, and it actually prints through the media. So you have all those colours actually going through the sheet of paper, each sheet of paper, so that when you cut, you get the variation of colour actually through the sheet. So the advantage of doing that is that we can actually have the same resolution on the top of the sheet as we do on the bottom of the sheet. So we can print upside down images, we can print overhangs. Yeah, so we can print something like a Sistine Chapel, if you'd imagine that. We would have the same resolution on the ceiling as we would on the roof.
Wow.
So we would have the same detail all around, overhangs, vertical walls, and upside down. And that has been a big challenge of the powder technologies.
Yeah, I imagine
because of the way they do that thing from one surface, we actually approach it from two sides, and we can get very high res. So that's one thing about the colour. The second thing about the colour is that colour ink has been designed to run on paper. So it runs very well going onto white sheets of paper. Plus our machine uses 4 cartridges, CYM and black. So between the black and the white paper and all the colours in between, we have a huge range of colours.
Right.
Up to 1 million colours and a very high colour fidelity. So the colour that you get on your screen is going to be very similar to the colour that you actually get in your printed part. So that's a very important part, and it's very repeatable.
Cool.
That is very cool stuff.
Beats hand painting it.
No, I mean, and the parts, the photos of the parts that we see look just amazing. By the way, so I mean, there's no question that this works, and it's
that grapefruit
really
looks
impressive
real.
stuff.
I tell you.
Yeah. Thank you.
So you guys have been hitting the trade show circuit pretty heavily this year. What kinds of feedback have you been getting from professionals out there? What's the good stuff? What's the bad stuff? What's the stuff that's been kind of shaping your future plans?
Yeah, actually, we've been on the go now for a while, as you know. So our first kind of shows, we started off in the UK, going to TCT, Time Compression Technologies show every year, and then we kind of ventured out into going into Europe, and last year then we started our first US shows. It was a very important part to us is into the US market, but we kind of at the trade shows, it's good and bad. So it's one story that does the good and the bad. So it usually goes through about 3 or 4 steps when people come up to see us at the booth. So the first thing they say is, you'd see somebody standing back from the machine, and they're talking to their friend and they say, oh, that's SLA, or they'll see the parts and they think it's some sort of plastic. And then you say, no. And you over here and you said, it's actually paper. And I go, what do you mean paper? So that's the first point.
Right.
Then you show them, they say, and the very first thing that they say when they think it's paper, they say, well, what can you do with it? So you go straight over to show them the parts. You show them parts that are like plastic. You show them parts that are used for sand casting, parts that are used for investment casting, for vacuum forming.
Wow.
And then they go, oh, really? And what's the cost? Then you show them the cost, and then they go through a kind of a circle. And they come all the way back. They come all the way back to the point where they say it's paper. And it takes it. So the bad is there's a journey we have to bring the people through. But the good part is that when we bring them back, when they get back to square one, they can just see the whole thing just opens up. It's like a light bulb goes off, and they say, oh my God, we could use this. And that's the good and the bad in a nutshell.
Oh, that's great. All right, Conor, the maker revolution.
Yeah.
You're part of it, whether you know it or not.
Yeah.
Where and how does your product fit into this this new revolution?
Well, I like to think, as I kind of alluded a bit to earlier, I mean, obviously things have happened lately in the last couple of years with the like of, from RepRap to Bits for Bytes to MakerBot.
Right.
And, that was really obviously the start of it. But I think if you went back a little bit further than that, you would say Desktop Factory had a big impact with what they were going to come out with. But I would like to think that we had a big impact as well, and for people to start to think, hey, we could do this. We don't have to be relying on these big buying off these big companies and them kind of making a lot of money on us on the consumables. So one way I'd say, I'd like to think that we had a kind of a part of it way back in the early days. How we kind of fit into it now, I think it's brilliant that the maker revolution is happening. I think I'm embracing it. It's a case of it's raising awareness about the technology to everybody. It's not everybody's cup of tea. There are certain people that love the maker, the kits, and they use it and they can get fantastic use out of it. And then there's some that can't. And as I said earlier, like the penetration is so small, there's enough for everybody. There's enough of a market for everybody to go after. So I think right now, it's a great space to be in. It's great to be a part of it, and I think it's it's very exciting how it's moving forward. I think in the future, the whole maker, those entry level machines, it's going to be a dog eat dog down there. It's like the machines are getting cheaper and cheaper and cheaper. I remember when RepRap and MakerBot were starting to come out first, and you're reading the blogs about it, and guys saying, "God, I'm not going to buy one until I can buy it for $100."
Yeah, right.
Like you're going to get people that just they're not going to use it until it kind of gets down into that level. But then what kind of business is there for everybody at that point? If it gets down to that point, I'm not really sure how that's going to pan out. But
and we think, we're big believers that actually having them at home may or may not actually be all that productive for people. I think bureaus and also just corner stores like Staples, for example, are going to be how a lot of people interact with these things. And it happens that you guys have a pretty, what I think it's a really big deal. You teamed up with Staples very recently to offer 3D printing at certain European stores. That is
envelopes,
cool.
Office chairs, and 3D prints.
3D prints, yeah. So tell us about how you got that to happen, and then what's kind of the future of that?
Yeah, well, as you said, I think it's going to go in two different ways. I think you're going to have people that will buy the machines at home, the kits, and they're the kind of guys that already are kind of into tinkering around with things, and they might have things in the garage and drill presses and maybe a welder and electronics, and they're kind of into that. And that'll go into other people that aren't kind of so much maker type of community. I know that will expand a bit more, but I do believe that I know people have a hard time programming their TiVo or their here the Skybox, and I can't imagine my parents have a hard time using a phone. I can't imagine them ever or people like that using a 3D printer at home. But I definitely do see that those kind of people would quite easily go down to a store like a Staples and say, here's a couple of images, can I get that as 3D print? Or here's from my mobile phone app, you zoom out around somewhere on Google Maps and say, I want that printed, like where I go on vacation, where I play golf, you know, all those kind of consumer type of things.
Well, I mean, what I always say to people is that I think there is a lot of analogous. Well, there's a lot of parallel between, you know, the desktop publishing revolution in the 80s and the 3D printing now. And I think, you know, for a long time, people thought that printing on your desktop was going to eliminate the need for offset presses in the world, which was absurd. Yeah. And turned out to be not true, right? And people also thought that the availability of software for this kind of thing was going to make graphic designers useless because suddenly everybody's a graphic designer, and clearly that's not true either. However, you know, with photo printing, folks are perfectly happy to go down to you know, Walgreens or Staples or wherever and get their photos printed, and that way they don't have to own, you know, have the overhead of owning a machine. And so I think it's not just about technical know-how. I think it's also just about, you know, economy and
simplicity.
Simplicity, yeah, it makes a lot of sense. Would you agree?
Yeah, absolutely. I mean, it's the same thing when the printers started to get cheaper and cheaper. 3D printers, people thought that the bureaus were going to go out of business, that nobody was ever going to start to use a bureau anymore because everybody would have a machine in their home. And what happened is that the bureaus got really good at making very high quality parts, and they made a business for themselves, you know, making parts that people would have a hard time making in their own 3D printer, and they kind of survived that way. So, you know, it just because it is changing, and I think that I do believe that the bigger growth, that the tail in the curve where the greatest usage, the greatest number of people using the technology will be through their local stores like Staples. And we're, you know, so the deal with Staples, you know, we were in contact with Staples. We went on the assumption that Staples were going after this consumer play, you know, because they would have a lot of consumers coming in and using their services through the regular stores. And we know from in the past that our competitors have tried to get into the likes of Staples. I'm not saying Staples, but other companies where you'd walk in and get potentially get stuff printed in a kind of a reprographics arena. But they weren't really able to pull it off. Either it was because of the materials, you know, or the extractions or whatever was needed, but mostly down to the price point. By the time you get a component, a part printed out on a kind of a one-off basis that would enable the consumer to come in and buy it without them having to pay a couple of $100s for it, it just wasn't really working out. Whereas with our technology, with the colour, even though the colour adds a little bit of price to it, but you get very high colour. You get a part that's very durable and very smooth, and then, you know, the price point means that, you know, the stores can make a bit of markup on it, and the customer can still afford to buy without having to, you know, think too much about it. You know, so when we ran the numbers and when they seen the quality of the color, it was just an obvious thing for them to do, and they're very progressive. You know, they really have thrown a lot of resources in behind it, and they're really going for it. So it's great, and they have huge expertise in doing this in the 2D printing arena. You know, managing files and data and managing regular print. So
they got a few reams of papers laying around there.
They would have a few left over. Yeah.
So when do you think we're going to see this coming to the U.S.? And for cost estimate, what might the cost of a full color print that is around the size of a coffee cup might be? I can't. Like, in terms of the cost, I mean, that's obviously up to Staples.
Really rough.
I mean,
are we talking about $10, $30,
Monday
$100?
And $15.
Yeah, you're talking. I would imagine you're talking in the tens. You know, 10, 20, 30, something like that, for something that was, you know, a good size.
Right.
Like, put it like this, it'd be, you know, you know, we'd have to wait and see what way they're going to come out.
Well, it'd have to be reasonably priced.
Yeah, but that's the whole thing. You know, there's no point in having parts that are coming out that are a couple of $100 because then just people won't print. But then on the as the terms of when that will come out in the US, again, that's driven obviously by Staples as a company.
Right. Monday, Tuesday.
But there is
something like that.
It'll be It'll be on a Thursday, I think.
All right, so one last
folks.
question for you, Conor. Have you guys, do you have any known plans to branch out into other markets at the moment? Anything you can share with us?
No, not really. I mean, we're, with this new product, we're concentrating on this product now with the color. So, there will be new machines that'll come in down the line that we're kind of working here in the R&D. But
I would like to see an app. At least if I was over in Ireland, I could shoot off a print with my app over to the Staples and go pick it up.
Yeah.
Yeah, I mean, it's going to be very exciting. I mean, the next. Like there's trials going on there at the moment, and eventually it's very quickly it's going to be going online. They'll be opening up online, and very soon people will be able to get their prints done. So
that is super
that
exciting.
Is great.
Yeah. Very, very exciting stuff.
Yeah.
Conor
Congratulations,
MacCormack,
by the way. Yeah.
MCor Technologies. Thank you so much for being on the show with us.
Yes.
Today.
No problem. It was good fun talking to you, Adam and Josh. It was good questions, and
yeah,
it was good talking to you.
Excellent.
Yeah.
I hope we can do it again sometime.
Thanks again.
Yeah.
Well, Adam, I got to say, that was a fun and interesting and fun interview.
It was fun and interesting and fun.
It's true. In fact, Adam, talking with Conor was even more fun than that time you attempted to snort peppercorns and shoot them out your eyelids.
Which time? Which time, Josh?
All three.
If you'd like to send me new eyelids, as everyone does these days, please address those to Adam and send them over here. I will most surely put them in rotation with my other favorite eyelids.
That's just weird. The no eyelids bit. That's weird.
You know what? Prosthetics is
prosthetic
is
eyelids.
Yeah.
Nice. All right, we love your comments. Please leave them and let us know what you think, what you want to see on the show, and what you'd like to hear about at EngineerVsDesigner.com or on the EVD YouTube or Vimeo channels.
And don't forget to stop by the EVD Google Plus community. And if you'd like to see see us really sad and confused and start to talk to ourselves and create characters like the Smothmealer, please be sure to like us, +1 us, tweet us, or whatever else, as social media has been correlated with losing your mind, screaming at yourself, and recording it for fun.
This show was edited by the masterful Simon Martin. If you like the tunes on the show, check out the Solid Smack Radio, where we'll bring the latest mix for your workday week.
Yeah. Well, this is actually
Tuesday.
This is one of my favorite new products we've been doing. I love this thing. Gotta listen to that
every
week.
Tuesday at solidsmack.com.
We'll see you next week. And remember, without designers, engineers would be working in cluttered boring office environments built for practicality, but smelling strangely of belly button fungus everywhere.
Of mahogany. And without engineers, industrial designers would spend more time assessing a space rather than working in it.
That's what I'm doing right now. I'm assessing the space between my fist and your face. Boom.
Boom.
Yeah.
Nice comeback. Adam, you are on your A game today, buddy. A game. You brought
Thanks,
it.
man. Well, all morning I was really rocking a B+ game, and I felt like, I better take it up a notch. And the next notch above B+, it turns out, is my A game.
A production of EVD Media.